But because of the hype of AI, because of all of the costs associated with AI, it creates this anxiety where teams are throwing away everything they've learned over the last, many decades in some cases about how to effectively measure our engineering experiences. And it's not even that we're just throwing away, we're making negative progress.
Welcome, folks. Welcome to HangarDX. This is a podcast about developer experience and how engineering teams solve productivity challenges at scale. I'm your host, Ankit Jain, co-founder of Aviator. At Aviator, we build verification platform for AI-generated code that creates guardrails for reducing slop. And today with us, we have Brian joining in from HangarDX. And Brian is a researcher, also one of the co-authors of Space Framework, has also done a lot of work with Margaret Ann for the last few years. So I'm really excited to dive more into metrics and learning about how the world is changing and also talk about Space Framework, how that has evolved. So with that, Brian, thank you so much for joining. This is a pleasure to have you here. I'm really excited for this session. Can you please introduce yourself for the audience?
Yeah, absolutely. And thank you for having me. I'm very excited to be here as well. So I'm Brian Houck. I study all things developer productivity, and I take a pretty wide lens in my work. I look at everything from how new engineering tools and workflows like AI are changing developer experiences, but I also look at how cultural factors, environmental factors, organizational structures impact the developer experience. And most importantly, I'm an applied scientist. So I really look at how can I get practical research that individuals, teams, and organizations can put into practice to improve their engineering experiences.
Amazing. And you've spent a lot of years also at Microsoft, kind of like doing a lot of this research, right? And Space Framework, I think, came from Microsoft officially. Was that? Or is that an independent research?
Yeah, so I spent just about 2 decades at Microsoft, and at the time that we wrote the Space Framework, it was a combination of GitHub, Microsoft, and then Dr. Peggy Story from University of Victoria. Now, since then, everyone has sort of scattered to the winds, but it did sort of get birthed from Microsoft and GitHub.
We've already heard a little bit of the story about Space Framework from Peggy. Maybe you can share a bit about what was your thought process, while starting that research? Because at that time, Dora already existed, right? So what compelled to create yet another framework? Or where do you feel maybe Dora wasn't sufficient?
It's a great question. And Space, it's just about 5 years old now. I came out in 2021. And it was a very unique time in the industry. And when I looked at things like Dora, I think Dora is phenomenal. I think the Dora Core 4 still hold very well. But it really is about delivery efficiency. It's not necessarily developer productivity, developer experience. And at the time, I was looking at how is remote and hybrid work changing the way that developers were able to do their jobs. And I was getting a lot of really complicated signals out of the metrics that I was using. And so an example is when Microsoft first moved to mandatory remote work in March of 2020, we could see that pull requests jumped like 20%. Our developers were doing a ton of work. And at the same time, Microsoft's stock price jumped like 15%. And so it's the developers were doing a lot more work that was yielding a lot more positive business outcomes. You could imagine executives look at that and say, yeah, this is amazing. We're being so much more productive. But we weren't actually being more productive. Our developers were working 12, 13, 14 hours a day because we were in quarantine. There was nothing else to do. People were feeling incredibly burned out because there was a lot of pressure from surviving a global pandemic and then also just from crunching at work. And what that really taught me is we need a new way of thinking about developer experience, developer productivity, beyond just looking at traditional output metrics or even, business outcome metrics in isolation. You really needed to look at lots of metrics in combination across dimensions to get the complete picture.
Very cool. So let's fast forward a little bit to today. I think this is going to be like more interesting part of the conversation, which is AI, right? It's hard to believe that it's only been 5 years since the Space Framework came out, right? It feels like it's been there for a long time.
Yeah, you're telling me.
Everything in the industry has changed. right? Like with the how software development is done today with everyone at this point, I would at least expect everyone that is not a very high strict compliance requirement is like mostly using some AI tools to some degree, right? The adoption is all over the place. But let's just talk about what does that mean for developer experience? Like what parts of space are still relevant? What things have changed? And how do you see that changing with some of the developer experience parts being changing with AI?
This is like such a phenomenal question. There's quite a bit to unpack there. Space, like one of the, I think, both strengths and weaknesses of space is not a set of metrics. Space is really a set of principles that, at its core says that developer productivity is nuanced, it's multidimensional, you have to look across lots of different angles, and it, proposes a set of dimensions. And I think those dimensions still hold. The challenge is the metrics that sit underneath them. And this is a place where, like, as an industry, I feel like we've lost our minds. And like, it makes me want to pull my hair out because AI is a means to an end, right? Like
Mm-hmm.
the things we are trying to accomplish, now with AI are the same things we were trying to accomplish before. We want to produce innovation quickly, easily, at high quality that leads to good business outcomes. AI is changing the way we get there, but it's not a changing, what we're trying to achieve. But because of the hype of AI, because of all of the costs associated with AI, it creates this anxiety where teams are throwing away everything they've learned over the last, many decades in some cases about how to effectively measure our engineering experiences. And it's not even that we're just throwing away, we're making negative progress. Like the number of times over the last couple of years where I've heard very senior, executives talking very publicly about, measuring lines of code coming from AI. Oh, 40% of our code base comes from AI. And I'm like, what in the world are we doing? We've known for decades that measuring lines of code is a heavily problematic metric. And so when I think about how are things changing now as a result of AI, I really think it's a reminder that we need to think of metrics in sort of like a hierarchy. And at the top layer, we should be measuring outcomes. Like, what are the top level things we are trying to achieve? Again, our innovation velocity, our top level quality, our business outcomes, those metrics should not change because we're still trying to achieve the same things. Now, what changes is how we get there. And I think of these
Mm-hmm.
more as diagnostic measures, even like these are data points that give us insights into how our systems are working, how the innovation is flowing. And here we have some brand new metrics, and these are things like AI adoption and token usage and things like that, that are never things that I would necessarily want to set top level goals around. Like if you set top level goals around token usage, you get token maxing. But they provide a lot of depth and color into the patterns that lead to those outcomes. And as a result, we have to, I think, reinterpret some of the metrics that we've always used. I don't think we throw them away, but I think we've reimagined them. And like the example I love to give is PR merge rate. I think, historically we wanted really high merge rate because otherwise what we're saying is our developers are wasting effort on code that gets thrown away. But
Interesting.
now, if I have a really high merge rate, if I could just like finish this point, now if I have a really high merge rate, like, does that mean that AI is making flawless code, or does it mean that we're just rubber stamping everything? Like, I don't know. We have to like rethink the meanings of some of these
Very
metrics.
cool. Can you actually like describe what PR merge rate is?
Oh yeah, like what percentage of created PRs actually get merged into your team branch,
Interesting.
and
So as opposed to getting closed or like just getting stale and
abandoned. Yep.
abandoned. Interesting. So even if there was rework done on the PRs while they're open, they're still considered as part of like successful merges. If
Yeah, if they
once
eventually get merged, that is a successful PR versus, yeah, and there's certainly very valid reasons why you don't merge every PR. You're experimenting with something, you're staging something, you decide to throw it away, your requirements change. And historically, if you want to minimize that because it requires a lot of effort to do everything that creates that pull request, all of the coding and the actual pull request process itself. But now that effort is a lot lower if AI is doing it for you. And so the meaning of that effort changes.
right. Very interesting. So I know you already kind of like talked about token maxing. Do you have any thoughts on why people started doing this, and like it seems like already things are going in the opposite direction. I almost feel like now it's a pendulum swing where people are trying to figure out how do we optimize tokens. Do you have any thoughts on like why there are like these kind of patterns emerging?
Oh my gosh, yes. So, I mean, I think measuring tokens is the modern equivalent of measuring, sort of lines of code. It is for me the like definition of a diagnostic metric. And I think the problem is many people made assumptions that token usage was telling us something that there isn't any evidence that it tells us. Token usage is a cost metric. And like those costs are real and growing, and we should be measuring them. We should be understanding how to leverage them most efficiently. But just because I'm using a lot of tokens doesn't necessarily mean I am using AI anymore. Certainly not any more efficiently or effectively. It doesn't mean that I'm having better outcomes. And I think people thought those things correlated, and that evidence just isn't true. It says a lot more about how I structure my context and the efficiency of that context than about the usage itself. And I think that it's in this rush to, oh, well, we have to justify, we have to show that we are using AI and show that we're sort of on the leading edge. And so it's like, oh, we want to use tokens, and we're going to have leaderboards that have tokens. And then suddenly people realize, oh, if we have leaderboards for these things, people are going to optimize for it. And
Right, right.
the increasing cost is like the economics are like, oh, no, we need to not do that. And so that's what sort of created that pendulum swing.
Right. I mean, it's kind of like the classic Goodhart law, where we are trying to, put metrics in front of people, right? I would want to still take a little bit of side of engineering managers, like probably even first line managers who are many times struggling with these things. They still need to measure or understand how their team is performing. And in today's world where a lot of code is done with AI, like how should they think about metrics? How should we build frameworks? We kind of like build Dura metrics, which are great to understand delivery, like even lead time for changes, really understanding where the bottlenecks are. Those kind of things helped. Are those things still valid in today's world? And how should engineering leaders think about building frameworks or metrics that would make more sense for their organizations?
Yeah, absolutely. I think the first bit of advice is you can't try to distill things down to a single metric. You want to measure across lots of dimensions because that acts as guardrails that make sure you capture, more nuance in the engineering process. I think you certainly want to measure across a quality dimension, and something like change failure rate, which is in the Dora Core 4, is still an incredibly valid metric. And it was valid before AI and is now valid with AI. Like we still want low failure rates of the code we're flowing through. I think measuring developer satisfaction is still incredibly important. Like if AI is causing our developers to find their work less meaningful, more stressful, they're burning out, like that is a signal we should be capturing. We should understand, we might be getting all these gains from AI, but what is the cost of it? And measuring developer experience, developer satisfaction by asking developers is an important foil for that. Where you can measure business outcomes, you should. That's typically hard to do. And ultimately, your overall innovation velocity. Like, we love measuring PR throughput, and I think PR throughput still has a ton of value. It is a garbage measure of individual productivity. It is now an even worse measure of individual productivity with AI, but I think it is an incredibly valuable measure of system flow. Can we move code efficiently through the system, or are there lots of friction points, bottlenecks? And it's, whether that's human code or AI code, we should still be looking at that. We should still be detecting like where are our bottlenecks? Is it code generation? No. Is it code review? Well, now probably it is. Is it, validation? Like, yeah, like that's probably where we have the new bottleneck. And you can't detect those if you're not measuring things like PR throughput. But then also just like all of the tried and true things like how quickly do we respond to code review requests?
Mm.
How much time are we spending in meetings? How much bureaucratic overhead are we having? Like the things that were always important are still important. And I think you should be thinking about not necessarily what are all the new metrics I need, but how do I expect AI to change the metrics that track an efficient engineering organization?
Can you maybe give like examples of like some things that are new that people are measuring that were not measured before or less useful before?
Yeah, I think that one example is not that it wasn't useful before,
Hmm.
but it was hard to do and thus wasn't worth it before. And that
Okay.
is measuring the entire sort of cycle of an idea. And so it's like from when we have a first planning construct of an idea till it is in the hands of a customer, idea to customer. Of course, it's what we always should have been measuring. Like, what is our overall innovation velocity? But it's really hard to do because you have to stitch together planning artifacts to coding artifacts to build and test artifacts to deployment artifacts. Really hard to do. We can use PRs as sort of a proxy for that. Well, PRs are becoming less of a proxy for that over time. And thus it's like, oh, this is a metric that like maybe we always should have been doing, but now we're going to be forced to as we move towards more of an intent first world away from a PR
Hmm.
first.
Very cool. Yeah, I mean, we also have a lot of thesis around intent first world, changing topic or maybe a related topic as well. With AI, especially now, I would say we are already sort of in a post token maxing world. I would say leadership or at least CFOs have started asking, how are we understanding the value or the ROI of AI investment? Have you found signals that can be used to understand that value? You already kind of like mentioned, being able to understand a idea from like kind of like a product from an idea to kind of like shipping that to the customer. So maybe the velocity of how quickly we are shipping value to the customer is a proxy. I always find that's always a very challenging thing to measure. What have you kind of like seen in your research? Like, where do you see sort of like the ROI of AI, more tangible ways to measure?
Yeah, again, I think the outcome metrics we always should have been using are
Hmm.
the outcome metric, like those are the lenses we should use to evaluate if AI is having a positive impact. And I think we see mixed signals today. And so as an example is clearly AI is increasing PR throughput. And that may be a little bit different organization to organization, individual to individual, but overall as an industry PR throughput is up.
Hmm.
Now, if you just trace that code through to deployment, there was a great recent study by the National Bureau of Economics Research that actually found that very little of the new code generated actually survives all the way to deployment. It's like maybe only 50%.
Interesting.
But
Wow.
so can we trace it through the system? But ultimately, it as we try to compare and draw correlations between our AI usage, our AI adoption, our AI consumption, and our outcome metrics, what do we see? As we use AI more, do we see PR velocity go up? Yes, clearly we do. But do we see change failure rate also improve? And there the signal gets a lot more complicated. I have not seen any evidence that with any sort of statistical significance, our change failure rate is any better, which means we're producing more and more code, but it's certainly not any more stable than it was. Turns out humans are really good at
I
writing
think
code.
it's probably worse.
Probably a little bit worse. Like that's exactly right. And it's like, and well, why is it worse? So I actually have a study that I hope to publish soon, where we looked across 8 different dimensions of code quality. So things like the maintainability of the code, the robustness of it, the testability of it, the readability of it, things of that nature, the security of it. And it's across all 8 dimensions, none of them had a statistically significant positive relationship with AI usage. And in fact, most of them trended slightly negative. And again, that shouldn't be surprising. Humans are really good at writing code. The question is, what's the ROI of having a human do it versus AI do it? And it's like I use this as an example of we should be looking across our top level outcome metrics. How do we see those changing relative to our AI usage? And again, it's like PR throughput is going one way. Is change failure rate going another way? What about developer satisfaction? How is that going? Because there's also research out there that shows as we use AI more, the relationship between our sort of productive output and our developer experience sentiment seems to be diverging. And that's like really concerning. And so it's like we should be looking at all of these things relative to AI usage.
Interesting. I know like satisfaction also plays a very big role in space, sort of like framework and many of the things that you research on. So there are two angles to it, I find. Like at least sort of like, I have anecdotal evidence, maybe you can provide more statistical, which is typical engineers have very high NPS when it comes to using AI tools. It's like, oh, it's kind of like, very easy to use, fun to use, like my capability to actually write code, like the amount of time it takes me to write code, all of those things have like become better. At the same time, we also notice the sentiment from senior engineers and staff engineers who have to deal with like AI slop and like the reviews is like, okay, people are submitting code reviews without even reading the code, like understanding and verifications. If we just think about, overall satisfaction from AI tools, like what is like the research say? What are kind of like, the current sentiments there? Or they're like sort of, I mean, you already touched a little bit on the trend sort of like diverging. So is it like at a certain point, to a certain point, it is useful, but after a certain point, maybe sort of it starts diverging? Like how are you seeing the research correlate?
It really highlights how complicated it is to run a good high quality survey because so much of it depends on how you ask the question. So I have a study just got published, The Space of AI, where we asked developers, like, are you happier? Like, how strongly do you agree with the statement that, you like your job better because you are using AI? And overwhelmingly, developers are like, yes, I like my job better because I am using AI. And that makes sense. Developers overwhelmingly feel more productive when they're using AI. And there's lots of studies out there, including from Peggy's story, that show as we feel more productive, we are happier with our jobs. Great. But when you go just a little bit under the surface, it's like, oh, but do you like what it's doing to your code review processes? Like, do you like what it's doing to quality? Do you even like what it's doing to your work-life balance? Because like now we feel all of this pressure to like keep up. And so we're working more and more and more. And it might be leading to a bit of a burnout epidemic. Again, the new triple debt framework on like how do we feel about AI contributing to technical debt, cognitive debt, intent debt? Um, and so I do think that there's a lot of nuance where it's like, oh yeah, of course I love AI. I love using AI. It makes me feel so effective. It's like, oh, but there's so much about it that I hate and it's like driving me crazy. And I think that's okay that there's that conflict, but it shows that like, oh, we need to think about how we are deploying AI beyond just accelerating coding, which is the thing that devs have always liked doing themselves anyway. Is like, how do we actually use it to solve these other new bottlenecks, these other new pain points?
Very interesting. So it also kind of like goes into one of the aspects. I think this was also part of the space framework was around the flow state and this whole idea we were talking about at least a couple of years ago around context switching. Like I almost feel like those things are thrown out the window. How have you seen or felt about like everyone is running like 4 different terminals or 4 different sessions, right? Like with Cursor or Cloud Code, Codex, whatever the tools they're using.
This is like, I think, such a timely question. And I think it highlights a challenge we have around the expectations of what the future of AI really, really look like. And
Hmm.
so again, in that Space of AI paper I mentioned, we included some research by this phenomenal UX researcher, Sarah Cesari, where she did observational studies of developers, like actually watched developers work with AI. And what she found is that even very senior developers who are very experienced with using AI, when they were put under even just a little bit of time pressure, they all reverted from sort of multi-agent workflows to sequential workflows. Well, why? Because like our brains aren't good at multitasking. Like that's not how the human brain is wired. And so we talk about this world where it's like, oh, we're all going to be managers of agents. And turns out that's really, really hard to do. And again, that's like not what we've been trained to do. And for many people, that's just not how our brains are wired. We like are really good at solving one task, moving on to the next task. And we see that like, oh yeah, we're all going to be managers of agents. Well, turns out not everyone has the skills required to be a good manager. Like I was a manager for 10 years. I wasn't that good at it. It's like, it's not everyone works that way. And I think tools can help. I think as our tools make orchestration easier and allow us to sort of like visualize what's happening better, that's going to help a lot. I think training will help a lot. But there's also just like we have to recognize that there's this gap between this idealized way we'll work as humans and like the way that human brains work. I think that's really challenging. And it's still so important. And so I recently published a case study in a paper called Engineering Thrive that looked at an organization of 3,000 engineers. And we ran an experiment where all we did was clean up sort of low quality, redundant meetings that people didn't need to be in. And then also sequence their meetings so they had bigger gaps of time throughout the day. So just calendar cleanup stuff. Why? To give people bigger uninterrupted blocks of time to do deep focused work, to get into a flow state. So it's like collaboration is incredibly important, but you need time to like really get into a flow state, and you can't have just a bunch of 30-minute gaps between meetings. Great. So we did this experiment, nothing to do with AI. And we found that the act of doing that, not only did it, of course, create more focus time, but devs took that time and reinvested it in coding. And the gains in PR throughput that they got from that were 2x the gains that we are seeing from AI usage. That's just like, because again, we need time to like get into flow state, to do deep uninterrupted focus work. And these fundamentals that were always important are still really, really important. And I think we need to sort of recognize that as well.
So do you see these kind of like similar patterns emerging when we're looking at organizations which are doing well in terms of like engineering principles, practices versus the ones who are not? Because like now AI tools everyone is using to some degree or the other. I would be curious to see or learn, where do the practices, where do the principles, where do the processes differ in sort of like high performing engineering teams versus low performing teams?
This is something that has been really, really interesting for me to look at, is like, where do we see sort of clusters of high performance, and like, what are the demographics and similarities between these organizations? And what I found is that the signals that are predictive of a higher, like an organization that is maximizing their value from AI, it is not any of the things I would have expected going in necessarily. It isn't about the age of their engineering system. It isn't about the size of their sort of engineering workforce. It isn't about the specific segment they're in. Is it a financial services company versus, client-side software company? It's a culture problem. It is like organizations who have a culture around, hey, we're going to experiment with new use cases in a safe way, and it's okay to fail. Organizations where leadership strongly advocates for using AI in new and inventive ways. Like, I found that organizations where leadership were strong advocates for AI usage had 7x the sort of daily adoption as organizations that didn't. Like 7x, that's crazy. And that's just a cultural thing. Training and skilling is a big one. Something else I've talked about a lot recently is that like the most effective way of learning new AI skills appears to be something that we call social proof. It's not sitting in a structured training and like looking, like, oh, all right, here's some canned content and like how you can use AI. Like that does work. That is valuable. But the most valuable thing is watching a trusted peer, a trusted colleague solve a real world problem. It's not like, all right, I'll go watch this video. It's like, oh, Ankit, could you like share your screen and show me how you did this thing? Oh, now I get it and I believe it. And it's like, that requires a culture of mentorship and like sort of like helping out your peers. And it's like, that's more effective than anything else anyone can do. And it's like, that's a cultural issue.
It's amazing. Like that's in some ways, like you're saying, is it's better to invest in the learning and to invest in sort of like even sharing of knowledge than to continue investing in newer tools.
That's absolutely right. And like, there's these really interesting patterns where it's like the more an individual uses AI, the better at it they get. Of course, like that makes total sense. But we can actually measure that the more the people around you use AI, the better you get at it. And so because like, and I think this is just like this delightful showing that like software engineering is not an individual activity. That is why collaboration is part of the space framework. It is, we learn and grow from the people around us. And it's like teams that work effectively as a team, turns out like they are separating out from the teams that didn't.
That's amazing. I know we are coming close to the end of the session. I would love to at least maybe, if you want to share anything else about like the space of AI paper that you wrote, kind of like anything interesting insights that you found from there that we haven't already discussed.
I think we've covered the big things. I think the important findings were that it does appear that AI is improving productivity, not just along dimensions of activity, like how much work we're doing, but it is allowing us to work more efficiently. It seems to have some evidence of positive impact on satisfaction, although I think that's a little bit nuanced. The majority of developers feel it is allowing them to deliver more business value to their customers. The one challenge, the one wrinkle is that communication and collaboration dimension.
Hmm.
That is the one dimension of space where we did not see a majority of developers say that AI is helping. And it is like, maybe not coincidentally, also the most undermeasured dimension of space. And I think that as we don't want to lose sight of how important effective collaboration is for our productivity. I can see that individuals who can't work effectively with can't collaborate effectively with their peers are 10% less productive. It's like we
Hmm.
need to be able to do that. And so we need to think about how do we, you know, how do we measure the things that allow us to detect where we have pain points in our collaboration? And that's, maybe measuring the effectiveness of our meetings, maybe, and you can do that subjectively and with telemetry. Like there are ways to measure that in practice. Measuring our code review processes, like how long do I have to wait for a peer like to pick up my code review? Like these are all collaboration measurements. And I
Hmm.
think we need to keep an eye on how do we make sure that AI isn't causing us to get more siloed. And so it's just like, oh, well, now I will get all my answers from AI. And it's like, well, that doesn't force me to learn and interact with my peers. Or it's like, my last point on this is like a fear I have, again, going back to code reviews, my fear is that code reviews go away because we have AI just do all of our code reviews. And I think like there are totally valid reasons why you want to do that. But code reviews are about so much more than just finding defects. It's about transferring knowledge and getting transparency on what my peers are working on and finding new ways of doing things. And it's like, as we automate some of that stuff away with AI, how are we replacing that incredibly important team building aspect?
That is such an interesting topic. Like, I'm actually doing a talk on this literally next week. I know this session will actually get published after the talk. We are doing a talk on, like, rethinking code reviews. This is
Love
at
it.
AI Engineer Conference, and it's exactly that, right? Essentially, my entire thesis on code reviews is not about code reviews, right?
Yes. Yes. I just like, I love that.
I'll share some of that recording, like once it comes out as well. But okay, before we end, what are you researching next? What is your sort of like on top of mind? What are some of the biggest questions that are still unanswered that you're still digging into?
I mean, I sort of always have a pretty wide slate of research projects. Like one of my next papers that is coming out explores the relationship between sleep quality and developer productivity the next day, right? Like something like really wild and out there. My next big research area is around something that we're calling agent experience. Like there's all of this research into what are the factors that allow developers to do their best work, but not what are the factors that have to be true to allow agents to do their best work. And it's if agents can't do the best work, then that puts a lot more pressure and sort of dissatisfaction on the developer. And so as I think about how do I maximize human AI sort of collaboration, it's the human side of that we should approach with, tackling developer experience problems. And the agent side we should tackle with agent experience problems. So do agents have clear context? Are they working towards clear goals? Is the information that they've been given like well scoped, or do you feed in the entire code base every time? And things of that nature. And so how can maximizing that agent experience, how do we define it? How do we maximize it? And ultimately, what does that do to developer experience?
Amazing. Would love to kind of like, share some of those research and learn more about it. Like as they come along, maybe we can do another podcast in six
Love
months
it.
and see sort of like what are the findings from those research. I'm also very excited. But I guess we are at time. So Brian, this was amazing. Learned so much. It's always an exciting session about research, how things are changing. Like you always have a broad understanding of the industries, brings in a lot of different perspectives. So thank you so much for making time. And thank you everyone who was listening. If you're interested in developer experience or work in DevOps platform engineering, you can also join us at, we do virtual sessions like these. It's dx.community. Again, Brian, this was a pleasure. Thank you so much.
Thank you so much.